Okay, so hello everyone. Today we are going to solve the question on prefixsum. In the last video, we have already seen the concept of prefixsum. So the question is equilibrium point. Given an array A of n positive numbers, and the task is to find the first equilibrium point in an array. Equilibrium point is in an array is an index such that the sum of all elements before that index is same as sum of elements after it. Okay, so if we see the example, the given example is 1, 3, 5, 2, 2. So the answer output is 3. So if you see the index 3, 0, 1, 2. Okay, so equilibrium point is at position 3. So here 3 is a position, so index will be 2. So this one. So before this index I is equal to 2. Before this, that is 0 and 1. So 1 plus 3 is equal to 2 plus 2. So we have to find such an index before which the subarray sum should be equal to the after this. Okay. So what we can do, the naive approach or brute force approach will be, we'll check the sum before each index and after that index. So for example, here 1, 3, 5, 2, 2 is there. So if we consider the index 1, so before index 1 the sum is 0, and after it is 5 plus 3 8 and 10 11 12. If we consider index as 1, so before 3 the sum is 1, and after it is 5 plus 2 plus 2, that is 9. We select the index 2, before sum is 4 and after sum is 4. So we got the equilibrium point and we'll return, but still I'll show the other indexes also. If we select the index as 3, then b equal to 5 plus 3 plus 1 is 9, and after equal to 2. And if we select the last one, then before sum is 5 plus 3 8 9 10 11, and after sum is 0. So after finding this all, we can see b is equal to either side. So before sum equal to after sum, then we'll return the that index. So how we can implement this approach is, first we'll take one look. Okay. So we'll write a function for sum. It's a public int. Okay, we have to write static int sum. Here we are going to pass an array, start index, end index. Yes, right. So here what we have to do, we have to return the sum from the start and end. So int sum equal to 0 for int I equal to start, I is less than int e plus plus. So here what we have to end equal to sum plus equal to AR of I. Then we have to return this. Then for index I equal to 0. So what we have to do, we have to call the function, right? So we have to call the sum function twice. One in after before, and another one is after. Like we have to find the before sum and after sum, right? So for before, what we have to do is we have to pass sum where okay. The start is 0 and end is also 0, but see here start we have to write 0 and end is 0. As we are considering this index, that means we are excluding this index. Okay, we have to find a position before which the sum and after which sum, I mean after sum and before sum should be same, so that element we are excluding. Okay. So that's why I here pass the start, so the sum will be 0 only. So yeah. So here what we have to do, we have to pass the I minus 1. Before sum will be till I minus 1 from 0, and after sum will be arrow from I plus 1 to till n. Okay, this. So from 0 to, let's say, this index. So what we are doing, from 0 to I minus 1 and I plus 1 to n. So these two we'll find, and if we get a equal to b, then what we have to return, I index. No. So we have to return the position. So I is the index, but position is I plus 1. If we don't get anything, then we'll return minus 1. If I run this, yeah. So we are getting index out of bound in 44. Okay, yeah. So here, uh, because we are passing n, right? So here, what we have to do, we have to pass then n minus 1, and here the same thing. Yeah. So what we did here, I'm passing start and end, right? But in this case, in the second case, from I plus 1 to n, I pass the n. So instead of n, we have to pass n minus 1, because the index is still n minus 1. As in the for loop, we are including end. Okay. So we are getting the desired output. So this is the now approach. But the optimized approach is, so see here what we are doing, every time we are finding the sum. So for this index we are finding 1 plus 3, for 2 we are finding 1 plus 2 plus 5. So see here, you can see, before I got this, then again I'm doing this 1 plus 3 plus 5 for next index, right? So there is a repetitive work. We already know 1 plus 3 is 4. Before we already have calculated it. But after that, again we have to add only 5 instead of calculating all the sum again. Okay, so we are going to optimize this solution using an prefix sum approach. Okay. So what we are going to do, uh, so if I find the prefix sum array, we already know the formula of prefix of I equal to prefix of I minus 1 plus arr of I. Okay. So here, if I calculate the prefix sum, it will be 1 plus comma 4 comma 9 comma 11 comma 13. So 1 plus 3 is 4, 4 plus 5 is 9, 5, 9 plus 2 is 11, 11 plus 2 is 13. Okay. So now I want to find the suffix array also. Prefix is from start, suffix is from end. So if I calculate from end, so at the end we have 2. So 2, okay. 2 plus 2 is 4, 4 plus 5 is 9, 9 plus 3 is 12, 12 plus 1 is 13. Okay, so we'll get this prefix array, the sum from int. So our array is 1 3 5 2 2, right? So 2 2, 2 plus 2 is 4, 4 plus 5 is 9, 9 plus 3 is 12, 12 plus 13. The same thing from the end. Okay, how we calculated the prefix array, the same way we have to find the suffix array. Then suffix array is the sum from the end, prefix is sum from the start. So we have to find, right, the first, like before sum and after sum should be same. So before sum will be in the prefix array and after sum will be in the suffix array for that particular index. If I show this, so before what we did, we excluded the current element, but if we add the current element in the both side, then also there is no effect, right? If I'm getting, let's say here in this example 1 plus 3 is 4 and 2 plus 2 is also 4, but if I include this 5 in both the cases, so 4 plus 5 will be 9, again 4 plus 5 will be 9, so both are equal, so there is no effect. So here we are including the current element also, so 1 and 13, right? So if I include this one, so before will be 1, after will be after will be 13. Then again if we use this, so before will be 4, 1 plus 3 will be 4, and after will be this all the addition of this thing, so that is 12. So we were checking this a is equal to b only, right? So here we already found the prefix and suffix array, that is 1, 4, 13, 12, right? So now here what we have to check, we have to check the prefix of I and suffix of I. If both are same, that means that index, so here you can see at index I is equal to 2, both prefix sum and suffix sum is same, that means before sum and after sum of this index is same. Okay, so let's write the code. We have to find the prefix array, so prefix and suffix. So first we'll find the prefix here, I equal to 0, I is less than n, plus plus. So prefix of, okay. So before that we know prefix of 0 equal to AR of 0, and we are starting I equal to 1. Prefix of I equal to prefix of I minus 1 plus AR of I. So now we have our prefix array. Now suffix. So we are starting suffix from the end. Okay. So suffix of n minus 1 will be AR of n minus 1. So here our what was our suffix array? Our suffix array was starting from the end. So uh, what we were doing, 2 plus 2 4, right? 2 was at the end, so last element we are checking and considering. Now from int I equal to what, from n minus 2 I is greater than or equal to 0, then I minus minus, okay, as we are going from the end. So suffix of what, I equal to suffix of I plus 1 plus er of 1. So here we have written I minus 1 because so the current element was so current sum was previous sum plus current element. Now in the suffix array, what will be the current sum? It will be the after sum. Like here 2 is there, 2 plus 2 4. So before I mean the after 2 and now the current. So I plus 1 sum plus the current element will be the current sum. So now we have prefix and suffix array. Now what we are going to do, we are going to check the prefix of I and suffix of I. If both are same, then we have to return that position. So position will be I plus 1. So prefix of I, if so, if prefix of I equal to suffix of I, then we have to return, but we have to return I plus 1, as in the question it is asked we have to return the position. Okay, so index plus 1 will be the position, and now we will return minus 1 if we don't get any such equilibrium point. If I run this, okay, yeah, so we did one mistake. So array is given in the long, but we have taken the integer. Yeah. So here you can see we are getting the expected output. So you can see. So this is the solution with using the concept of prefix array and suffix array or prefix sum. Okay. So yeah, thank you.